Today we're going to go over graphics or technical sketching. And as engineers, that is one of the tools that we need to do and use. If you remember, we talked about communication, and one of the communication skills is visual communication. And being able to sketch something or draw a technical sketch or even any kind of rough sketch is very important. What I want you to do is quickly take out some scratch piece of paper and draw something you're very familiar with throughout the day, something that you're really familiar with or that you may use. Just take 1 minute. You can pause this video real quickly and then do that sketch. So hopefully, as you review your sketch, you can kind of take a look at it. You can notice that it really makes sense what you've drawn, right? You could take that to anybody and they could tell what you've drawn. And that's, again, that form of communication, that visual communication skill. So engineering graphics, when we hear that term, it really means that it is a communication of technical ideas. It is a clear and precise language, just like any other language with well-defined standards. While we don't have verbs and everything, but there are certain things and verbs and adjectives and things like that. There are things that we do when we do sketches as a technical sketch that are part of its own language, its own grammar, you could say. These standards are used by everyone, regardless of background, who can read drawings or not. So if you can pick up a drawing like a blueprint, I tend to think of blueprints on homes, and you can kind of figure out what room is what and what are doors and what are windows and things like that. So these standards are important to help everybody understand what's going on. There's three main reasons for engineering graphics. One is visualization, right? Visualization is really the act of mentally picturing a non-existing thing. Visualization is vitally important when engineers design systems. An engineer must be able to mentally see how a part will function with other parts in the system before it is actually built. And engineering graphic aids us in this visualization by specifying the size and shape of a part to determine if it will function properly in the whole system. So if this is what I'm looking at, if I'm able to draw this, you'll be able to tell what that is through some sketches. So being able to visualize it and then actually sketch it. Communication, right? How do we communicate our ideas then, right, with these graphics? So graphics is a form of communication, and it's used to communicate with customers. It's used to communicate with other engineers. They can look at it and determine what it is. Like customers, they can look at blueprints and things or other components. It is used by fabricators, people who are going to build what we're designing. By management, they may want to know what it looks like, or marketing. Quality control needs it for knowing what standards they're going to base their dimensioning and quality control of the part of, right? Our drawings will dictate to them what we're trying to hold in precise alignment. Assemblers can use it to assemble everything, and really essentially it's used around the world. I worked for a company out of Germany and over in this area actually, over in Germany, and they sent us drawings, and yes, they were in German, written in German. And I could read some German, but I didn't have to. I could just look at the drawing itself and understand it. Likewise, we over here could do our drawings and send them back to Germany, and they could understand what our drawings were, even though they could also read English. But there's a pretty much standard. There's some changes to it or some differences between the areas, but a lot of it is very much the same. So documentation, I'm going to quick kind of go. Documentation really is engineering graphics is meant for us to record and produce the design created by the engineers. Graphics gives us a clear and concise description of our design. And graphics details all the information necessary to produce the design. It also serves as a record of the design for future repairs, builds, and redesigns. And documentation is needed for ISO certification, for the FDA, for a lot of regulations that are also used. So technical sketches, what are technical sketches? It's really a rough preliminary drawing. It represents the main feature of the product. We do this freehand without any drafting or tools or anything like that. And we might say, well, why am I doing this when I can go to the computer and I can give you a real nice, pretty, layout of what it is on the computer using CAD, right? Computer aided design. Well, the reason is it is much quicker, right? It's a very quick method. And if you're at a meeting, you don't want to spend a lot of time, especially if you're going over ideas and you're in the idea concept phase. You want to be able to get to the board and sketch something, or on a piece of paper sketch an idea and share that. You don't want to say, wait here for 2 hours and I'll come back with something on CAD and you'll understand it then. You don't have that time. Ideation or concept generation is a quick method, right? It's that brainstorming method. So we need to be able to sketch things rather quickly. And how do we do this? We use tools such as just regular pencils and erasers and just regular paper, typically just regular printer paper. And the process that we use is really trying to gather the information that we see with our eyes. So here's an object that we're actually looking at, let's say, and we can draw this sketch. If we don't know what it is, like the one we had in visualization, right, it's in our head, we have to skip looking at this and we have to try and pull it out of our head to be able to represent it, right? So seeing what's in our mind and putting what's in our mind into the drawing can be rather difficult, but it's real important to be able to do as best we can. It doesn't have to look artistic like these are with all the shading and everything to be able to get the ideas across. Some methods that the book talks about are contour sketching, and if you look at this, this is just the outside shape of an object, and if you look at it, you probably know right away instantly that it is a stapler, right? You could add additional contours to it, some of the internal contours, and the contours are just really the differences between light and dark, right? Or just different shading, right? Just lines that you see on the object. So if you look at an object like the stapler, you probably see these different lines. And that will give you what the object is. The book goes into detail on contour sketching, and I would recommend that you read that. The book also goes into the idea of upside down sketching, which is really important, and I would recommend using this one also. There's one in the book also called negative sketching, which I don't use, but you might find it to be useful. But upside down sketching is nice because you take the object that you want to sketch, put it upside down, and try and draw it. And because you aren't familiar with it being upside down, it's harder to draw and you pay more attention to the details of the object and you actually create a much better drawing. So when sketching, one thing you may want to do in drawing with like a line is to start at one location, like here, and put a dash, and here's another dash, and then I like to go back and forth until I think I've got a good line going. And then I just kind of fill it in, right? Yeah, and it kind of looks like this. It's not perfect or anything. I don't really like to keep lining over and over and making it heavier. I like to kind of practice back and forth and then fill it in. You can also do that using your hand as a guide, right? Your fingers are guiding along this page. So you can draw this nice straight line, right? Or you can use a strip of paper and do a mark on it here and here, and then you can mark as you go down, or you can use your thumb kind of as a guide to be able to draw these marks so that you can then fill it in with a nice straight line. So we want to be able to make these nice, good quality lines like this, right? So kind of not so good lines, not poor, uncurved ones or jagged ones like this. We want to be able to draw a nice freehand sketch. So just like the horizontal line, the vertical line, I do the same thing. I do a mark at the top and bottom, and I kind of go practice up and down. So I think I have it right. And I'm not sure why it's blipping out like that on here, but it is for some reason. Same with vertical lines, or not vertical, but inclined lines, right? This is the direction you would use if you're right-handed. If you're left-handed, you may go in the reverse direction. Curved lines or curved sketches are much more difficult, but again, you can use guide points to help you with it, to draw them, right? So you might draw a four-point circle by putting in some measurement. You can measure it with a piece of paper or your finger, and you kind of measure where these locations are. and then you kind of start and draw around in a circle. I'm not sure why that does that, flipping out. And then you can continue all the way around, maybe continue the same direction, maybe feel more comfortable going in the other direction to finish your circle. Here are typical lines. In this class, we're only going to be kind of concerned about visible lines, which are solid, thick lines of objects that we see, like our contour lines. Hidden lines are things in the object that we don't see. So if I'm looking at this object, which is the same object up on top, I have a hole going through it, so I have these dashed lines. These dashed lines are called hidden lines. We know that that hole exists. We can't see it, but we have those dashed lines there. And I'm not worried about the size of it and everything like that. I'm not looking at it. If you look, we also have, we do section lines. We're not going to talk about those in here. These are the dashed lines. And center lines are also drawn. We won't worry about those. But the center lines kind of tell us where the center of the hole is, which is really important if we're going to drill, right? We're going to drill a hole. We need to know where that center is. I don't care where the edge is. We want to know where the location of the center is. One thing I will want you to do is to draw something in proportion, right? So you may want to have an object. You may want to draw some outline size of the whole thing in width and height, and being able to draw this thing in proportion. So that's what this sketching kind of does. And the book goes through this too really well. Or you could use grid paper to help you do this with great. One type of multi-view sketch is called a multi-view, where you're showing everything in 2 dimensions instead of a 3-dimensional isometric view. This can be done, let's say you're doing your sketch of your car. And why don't you take out a piece of paper and try that, right? Stand right in front of your car, look straight on, and draw the front of your car. And it may look just like what this is. But you can pause this and you can draw that. And you draw it down in this lower left-hand corner down here. Next, you'll walk around from the front to the side of the car, walk around towards the right side of the car, look at the car straight on, and line this up between the 2 views, and that will give you your side view. That's the height of your side view. After you've completed your side view, walk back around towards the front of the vehicle. Now that you're standing right in front of the vehicle again, we're going to put on a cape, and we're going to put on a nice little cape, and we're going to fly and hover over the top of the vehicle with our toes at the front of the vehicle and our head towards the back of the vehicle, and we'll draw the top of the vehicle. Now we have the top of the vehicle. So this gives us our width, this is our height, and both these views give us depth, right? So all 3 views only give us 2 dimensions, but with the 3 views, or the multi-view drawing, we have all 3 dimensions, so we can create this object. That is our multi-view drawing. Another way of doing this is, let's say we have some initial object. I could take that object and put it in what we call a glass box. And this glass box, then we can take a picture from the front, which is always in this direction, the side, which is always this direction, and the top, which is always this direction looking down. And we can project the lines out to that glass plane, cut it open, and we will have our multi-view drawing, right? You'll see this little icon over here for this glass box program. It is on Excel, or not Excel, in Canvas, and it looks like this, right? You can start the program, and it goes through the whole glass box theory. I'm not going to run through it, but you can run through it on your own. And it will go through the projections for each of the views and eventually cut it open. I'd like you to spend some time with this program. It's a good little program to use. All right. The last thing I want to show you, this is an example of a full drawing. And it has lots of different types of views on it. It has section views to kind of describe it. It has isometric 3D views. It has a front view here, a detailed view. I mean, these views can get very, very complex. But I want you to spend some time doing these types of drawings. And if you have questions with any of the graphic stuff, please let me know.